All right, so we're live. So good morning, everybody. Welcome to the yet another ONOS TST meeting. This is a public and recording meeting. Today, we're going to continue our track of providing updates on the progress of the µONOS project. We don't have any huge presentations or anything like that unless individuals do. Mostly this will comprise of just verbal updates and demonstrations of some of the new features that were developed over the course of the last 2 weeks. So, Jordan, do you want to start? Are you ready? Or should we start somewhere else?
I'm actually getting set up still. I'm running a little late, but
oh, no worries. No worries. Adib, do you want to, let's take it from the bottom then. Adib, do you want to provide maybe an update on some of the...
Yes. Actually, I'm implementing 2 features for the simulator. I'm expanding the subscriber stream to support the sample stuff, sample mode. We already supported unchanged. So it has 3 modes: sample, unchanged, and target defined.
Mm-hmm.
So unchanged is already implemented. And another feature that I'm working on, retrieving data for the get operation based on a given data type. Currently, we return all of the config, state, and operational values without filtering based on the data type. If we provide the data type, so we would like to return as a subset of the lit values. So for the config, for the state. So I had a good progress on that. So hopefully, if everything goes well, so I will give a demo for the next TST.
That's great. Thank you. We also added an administrative interface for registering model plugins and documentation for this. Is this something that you could cover? This is something that Sean did, but
I can cover, Tom.
Thank you, Andrea. Go ahead.
Let me take the presentation rights.
Yes.
Can everybody see my screen?
Yes, we can.
Yes.
Yeah, so the idea is that thanks to Sean, we added a few model plugins containing the Yang models for the different devices. For now, it's simulator and test devices. We do plan to do the Stratum ones, but but we have not pushed them yet because from a set of reasons. There's still a lot of things to do in here. If somebody wants to do their own, I would encourage to take a look at the model plugin generator.sh script and the model plugin.md page. This is basically gives you an idea of what we're doing exactly and how we're bringing in the Yang models to ONOS config, and it enables you to start bringing in your models, putting them through the model generator plugin, and that basically compiles them and enables YGOT and enables us to use YGOT to do verification against them. The verification part is still ongoing, meaning that we have done some of it inside ONOS config, but the main bulk of the work is yet to be done. So at the moment, it's still a fully optional feature, meaning that it's not turned on by default. So it's still all the paths that are still configured are not still checked or not yet checked by the Yang models, but at least now we have the capability to inject them both at startup time of ONOS config, but also at runtime, thanks to the admin interface that Sean put together. This is basically a CLI command of the CLI of ONOS config, based on Cobra, that enables you to load plugins at runtime to ONOS config for a specific device. So again, just please go through this. It contains an overview of what it does. These are the few commands like model load, the list of commands, and this is how we're going to use them with Genemi and in particular an example with OpenConfig. Yeah. Another thing that I want to point at is a little bit of documentation about the Genemi extensions that we're using. This is something that you maybe have seen in other type of commands like the get and set does have these extensions. Again, these are fully optional. You can avoid specifying them, but if you do specify them, it gives you a little bit of more flexibility in specific of targets and managing configuration objects. At the moment, it's like 3 extensions. So 101, 100, 101, and 102, which they take care of mapping a specific network change name that you want to a specific network change that is saved in ONOS config, the 102. The 101 is the device version. We now have the capability of dealing with multiple versions of different devices, meaning, for example, the 1 version or the 2 version, may depending also on the Yang model change, something that Sean talked about. It's now documented here. And also the device type, because we might have an open config device that is specific to some like optical things, and that can have a configuration depending on only the optical stuff. So that's the device type. So again, just take a look at the documentation, and if you have any questions, just feel free to reach out. That was that point, Tom. And if you don't mind, I'll still take control.
Sure, yeah.
To show everybody the update of configuration for a non-existing device, and also the delete option that we now have.
Okay, Andrea.
So,
Andrea?
yes.
Yeah, just a quick reminder to everybody. The primary motivation for the model plugins is to allow us to compile all of the Yang models together so that they can be validated in the presence of all of the deviations or augmentations that may exist for a particular device. That's all. I just wanted to just toss that in so that for people who are new or are joining us here, so they know why we're doing it.
Okay. Yeah. Absolutely. Okay. So again, the first thing I want you guys to show is that I have 3 simulators running here. And what I'm doing is that during initial handshake of the device, I'm trying to see if that device has, for its target, it has some configuration. If it does, what ONOS config does is that it creates a full set of changes for that device, containing all the updated configuration set state that has in its store, and tries to send it down. So in particular, I want to everybody to focus on, maybe this is a little bit small, but
yeah, you can bump up the size, that would be good. Yeah, perfect.
So what I'm doing here is that as soon as the device connects, that it checks the capabilities, and this is the standard stuff, but it's also getting the initial configuration for the localhost 1 device, and it's trying to set it. When we try to set it, we're still hitting an issue that we are currently addressing, which is the fact that we're sending it down in a string format. And so the device simulator, which needs the type of the device, needs the type of the value to be specific and not just string, it rejects the configuration. But this means that ONOS config is properly computing the latest update of the configuration based on what it has in its store. And I primed the store with a few set of configurations that I can show you, which is basically what is present in the configuration in both in the config store and the change store. So I primed in this case device localhost 1011 with the 2 changes. Those 2 changes basically try to apply some OpenConfig related things in here. And we're actually failing on this one because we're sending it down as a string. It actually expects it as a different type of value. So that means that up to the point of sending it down to the device, we're properly doing the same thing. We're well aware of this this issue of dealing with the type. I just want to wait for Sean and do this right, because it will bring in the YGOT verification and different elements from the Yang stuff that we discussed before. Something else that I want to bring everybody up to speed on is the fact that we can now do properly delete paths on devices, both in terms of configuration inside ONOS config, but also on the device itself. So if I do a query at the moment on the first device, maybe, let me do this. So if I do a query on localhost 10161 to for the time zone name, I get Europe Paris. Now if I go here, and let me zoom in this too so you guys can see it, what I'm doing here is I'm doing a set request, because this is how GNMI does a delete, but I'm doing a set request with a delete option in the protobuf. So to do a set, which we have here, we have an update field. Instead of the update field, we have a delete field. With this delete field, what we'll do is that we will go to ONOS config, and for the specific localhost 1 target, we're going to just delete the value of the time zone name. So that's fine. I just want to mention to everybody that's the operation delete that happens. And if we do now go and check the device, it will say that it's not found because we just removed the whole path from its store. Yep. So that was the delete option, and we can also see elements in the logs of ONOS config. Okay.
Great. Thanks, Andrea.
Any questions? Okay. No. Thanks.
Very cool. Thanks. Who's on the next on the list? Well, Jordan. Jordan, are you ready? You wanna?
Yep.
Take the helm.
Okay, so yeah, so at the beginning of the last 2 weeks, we started sort of working on, we were trying to find a solution for basically running integration tests on Kubernetes. And there were like a few approaches to doing this. And ultimately, the approach that we were interested in was basically an approach that essentially runs the tests inside of a container on Kubernetes against the cluster that's in Kubernetes, and then queries the Kubernetes API to get test output. And so we started working on this, and what basically came out of it is this sort of test framework that uses a lot of the features that we liked in STC and vanilla ONOS, except implements them on Kubernetes. And so I'm going to show just a demo of the script that we built, all the tools that we built. So yeah, so what we added to ONOS config is this command that's called ON.It, which is like, I guess, open networking integration tests. It's really, I named it ONOS IT and then just shortened it. So you see the ON.It command has all these different subcommands for basically managing clusters, creating, deleting clusters, adding stuff to the cluster, and I'll show you some demos of this. So basically, given, like I have a Kubernetes client connected, so I have a local Kubernetes and Docker cluster running. Given just a local test cluster, you can just do ON.It create. And you'll see what it's doing. So basically when I run ON.It create cluster, it's, well, it says all the things that it's doing in Kubernetes. It's setting up a test namespace named cluster, blah, blah, blah. Sets up atomic, sets up graph partition. So, I mean, one of the goals of, or one of the purposes of doing this now was we're starting to work on the stores, and we really need something that makes it really easy to set up the cluster with the store, run tests against the cluster when it has real stores, real raft partitions running, and things like this. So that's why this is being built. Yeah, so it's setting up raft partitions, and if you go and look at like get namespaces, you'll see that it created a cluster namespace. And inside that namespace, created an atomics controller, created a raft node, which is still starting up. And then you'll see it create an ONOS config node once that's done. So while it's doing that real quick, there's pretty good documentation on all of the stuff that I'm going to show. So in this new testing document, it shows how to set up and configure the ON.It command, how to set up the environment for Minikube or kind, and then how to use all this stuff. So I encourage you to go play with it and test it out. Yeah, so it's done setting up. So so yeah, like I said, you'll see that in the list of pods now, I created an atomics node, a raft node, and an ONOS config node. And the ONOS config node currently is just configured this. So, I mean, when it starts up the ONOS config nodes, it configures them based on the current configuration of the cluster. And what I mean is I can do something like ON.It add simulator. So this will, this is setting up a device simulator. So you'll also see that get added. So yeah, this device is a new simulator that's been added to the cluster. And once it's started up, it reconfigures, well, currently it reconfigures ONOS config to add that to the stores because the stores are static, but I'm sure this will change in the near future. Yeah, so it reconfigured ONOS config and redeployed it. See what else we got here. Yeah, and then given a, so you can like view a list of clusters and view view the devices that are deployed and things like that. And once you have a cluster set up, the way that tests are run is just through the run command. So this run command basically just takes a test, and Ray will show what the actual test looks like. So it takes a test, and it will deploy it on Kubernetes, run it, and then get the output and return it. So see what test to run on it. And test. See what happens. Yes, it's. Yeah, I did not do that correctly. Yeah, so if I look at the resources again, that was a failed test. So you'll see that it created like a, let me see, get jobs. So it created one test job for the failed job that I created, one test job for the successful test job I created. The job. So a job in Kubernetes is basically just like a one-time run of some container that can be retried a few times. And so we create a job that creates the container, runs the test that I told it to run, and then you'll notice that this when the on.It run command will actually output the same exit code that the actual job did. So that information is retrieved from the Kubernetes cluster. So yeah, you can also get like a history of past test runs and their statuses, things like that. There's a bunch of other, we're slowly adding commands that will make it more convenient to debug clusters. There's like on.It get nodes, on.It get logs. Yeah, so you can get the logs from a node or from a simulator or from a raft node. for atomics debugging, things like that. Yeah. Let's see if there's anything else. Yeah, and then when you're done, just delete the cluster. That's it. And Ray will talk about the actual tests.
So currently you're running it on your local machine, right? But the idea here is that if we have a Kubernetes setup running, let's say on one of our shared cell machines, you should be able to, in theory, point your on it, just like your kubectl, against that remote machine and run things there, right?
Yep. Yeah. So that is still work in progress. Well, so currently we'll work on any Kubernetes cluster. So I mean, basically it uses the same client and the same environment that kube-control uses. So any cluster that your kube-control is connected to on it will also connect to it. The thing that's still being worked on is switching between clusters and things like that. I actually have an open PR for that, but yeah, pretty soon you should be able to also seamlessly switch between Kubernetes clusters and things like that.
That's awesome. Great job, Jordan. So you ready for Ray to take control?
Let's see if I can do this right. Okay, so Jordan just showed you kind of a very neat way of running a bunch of stuff together. And the idea was we really want to be able to test the interactions between components, particularly as we have simulators for things like the device we have now. We'll have one for Stratum at some point. So what we did was we wrote a few sort of demonstration integration tests. The idea behind these is, as I said, they can do a request from a client that exists outside of ONOS through one of the northbound APIs all the way down to a device, and then get results back to check that things work the way we expected them to. Right now we have, I'm showing you this page here under test integration. We have some support methods for GNMI and Protos. We have a registry, which is a really cool thing that Jordan implemented, which is how the onit command can find things like the single path test. I'll show you in a minute. There's a connection in the source between the actual test program and that name. And so that's the bridge between the two of them. We currently have 3 tests that we can run. One is a single path test, which Jordan just showed you. That's sort of a basic, think of it as a CRUD test that says, hey, throw a path on this device, check that it got set correctly, delete it, check that it got removed. We have a subscribe test that Andrea wrote, which is doing a streaming-based subscription to changes from a device. And then we have a transaction test that does a rollback. So what it does is it tests 2 things. It tests that you can have a transaction that sets multiple paths in a single request, and then it has a rollback call to make sure that you can unwind those. So I'm just going to give you a little bit of a flavor of what these things look like. Jordan showed you how they run. I had this command window up here. But like, for example, here we'll run the subscription test. You can see once the cluster is up, these things run really fast, which is really important. One of my goals behind this is I really want to make this all run on Travis. Kind is a very simple Kubernetes implementation that in theory runs anywhere Docker runs. So the idea is we could run this now as part of our acceptance test for new check-ins. And if we do that, it's important that it runs quickly. This is an example of what one of the programs looks like. So you can see anyone who's written Go code, you can see right away this looks a lot like what a unit test looks like, which is one of the things we really like. So you can do the things you're familiar with in tests. You can do assertions, which makes it look very much like the code people are used to writing. What this test is doing, this is the single path test. This is the CRUD one I was telling you about. It's not that important what it's doing. It's basically creating a client up here, checking the values, setting the value, checking, delete, checking.
kind of stuff you would normally do in a test. Here's a little bit of magic I was telling you about. So this here registers the name test single path test with a registry that allows it to be referenced by ON it. And that's really important because now you don't have to fumble around with what Docker is this thing in and how do I find it and whatever. ON it does all that for you. So it's really nice. All you need to do is know that key name and then you can request it. So as I said, the idea is we want to be able to make these run on Travis. Jordan has come up with what I think is a neat idea akin to this registry. We also want to have a way of registering sort of groups of interest. So for example, the 3 tests I just pointed out, we could call them integration tests, for example. And then you could do on it integration tests and would run all 3 of them in sequence. So that would be something that's really nice for like CI, because now when someone adds a new integration test, it automatically becomes part of the package if they do that registration. You don't have to actually change your scripting, which is really good because those are the kind of things that get forgotten. So anyway, that's where we stand on integration tests. I think Jordan did a great job with on it. It made my life much easier getting these tests going. And Andrea was able to write a test in about, what, like a couple of hours? So I think
yeah, I mean, it was more the hassle to get the subscribe working rather than have on it itself working. Once I got the gist of it, it's like 3 commands. It's very easy. Yeah. If you go in the subscribe test, I can talk a little bit about it. The idea is just that I took Ray's update test and just added a subscription. So before doing anything, I subscribed to the path we're changing with a specific base client, which is the same one I use in the southbound of ONOS config. I knew it very well. And I actually pass, if you scroll down, right, I actually pass a proto handler there as a subscribe response. And what that does is it pushes down to our response channel. And I read exactly what I expect from the response channel. I read 4 replies and no more than that, because I get 2 replies when I do an update and I get 2 replies when I do a delete. And that does the exact checking of those. And it's, yeah, and it just passes. Yeah, exactly. That is where I read. So after I do a set, I expect something back. And this can actually be taken and used as a base for any app that does GNMI operation against ONOS config. It's the exact same code, I think. Instead of the assertion, you're just going to do something else. But it was very easy to write against on it and setup that Ray and Jordan have done. And the same magic that Ray was talking about, if you scroll up to here, I'm just calling it subscribe-test and doing in the registry.register subscribe test subscribe. That's it. Nothing more than that. Okay. Fairly easy.
I think that's it for us. Very cool. So I think one additional change that was done outside of the integration testing, Jordan, you reworked the way we're building, right? This is probably like a 3rd or 4th pass over how we build stuff since we had a meeting in Milan. I think this achieves pretty good compromise. Do you want to talk about
that? Yeah. Yes. So so the problem that we were running into was that basically building things like the Docker. So we're slowly adding Docker images, right? We have a ONOS config Docker image, an image for the CLI image.
Give up command. There we go.
Yeah, so like in the build folder in the ONOS config repo, you'll see, so these are all Docker images that we're slowly adding, right? There's a CLI image, a ONOS config image, an ONOS config debug image, which I added that actually runs the container with a debugger server, which, by the way, I'm working on integrating debugging also ends on it currently, and an ONOS and the image that runs the test. And so the way that we had it set up was basically inside each of these Docker files, we were basically redoing the build, and because every time the code changes, the repo needs to be copied into the build, and then all the dependencies need to be pulled back in because of how Go dependencies work and things like that. Basically, what we were doing was pulling all the dependencies 4 times when you were building all of the Docker images. And so that's obviously a huge pain. And so I went searching around, trying to find a way to get around this. I mean, ideally, we could come up with some solution where the dependencies were copied from the host into the Docker container. And unfortunately, there isn't a really elegant solution, to this. But so what I had to do was, so what I had to end up doing was, basically, I added this image called the ONOS config base Docker image. And so this base Docker image is basically an image that all the other Docker images are derived from, that will hold all the dependencies. And so by doing that, we ensure that the image, well, at least the dependencies, the dependencies and all the artifacts only need to be built once, and then they're copied into the other Docker containers. And what we do to avoid even downloading the dependencies every time we build this base Docker image, which has to be built every time the code changes, is we just use Go mod vendor. So we switched to Go modules recently, and one of the debates when they were creating Go modules as an alternative to Go deps is whether to keep vendoring. So I'm kind of glad that they did keep vendoring, because vendoring seems to be the only elegant way to basically get a directory that has all of our dependencies from the host and then copy them into the Docker container. And so that's what this is doing. It basically creates a vendor folder that has all the dependencies. And then when the code gets copied into the image during the build, like when we look at the base Docker image, Docker file. Yeah, so I mean, basically what this just does is copies the root. So because we are copying the root after the vendor is created, that means all the dependencies get copied from the host, and then just calling make build. So make build will create all the binaries, and then when all the other Docker files get created, like ONOS config gets run after that. So ONOS config is now extending from ONOS config base. And then basically, all it does is copies from the base, copies whatever it needs from the base, which already ran make build. And by doing that, I don't remember the numbers. Our builds went from like 10 minutes down to 1 minute to 1 minute, less than 1 minute usually. 30 seconds.
And also, most of all the incremental builds don't pay the ridiculous penalty like they used to.
Yep. Yeah, so it's been huge for, especially as we're moving more towards Kubernetes. Basically, every time you make a change, if you want to test it, like with it, you have to rebuild the images, and that's insane to wait 10 minutes every time you make a change. So that's been a huge productivity boost from that sense.
Yeah, we'll have to figure out once we start, splitting, start working, for example, on the ONOS control and ONOS topology. We'll probably have to figure out how to set up some neutral ground for some of these recipes and patterns to make sure we don't repeat them, and to make sure that the other repos and other kind of sub-projects get to benefit from these improvements as well. This is great, Jordan. Thank you. I think, unless I'm mistaken, are we forgetting? This is pretty much all of the pieces that we were working on over the past two weeks. Am I forgetting something?
I don't think so. Sean's been out, so there's sort of a gap there.
Yeah, he'll be coming back, I think, after 4th of July, right? So in the space of about 10 days.
Yeah, I think that was all.
All right. Well, we'll set up another TSD meeting 2 weeks from now. anyway, keep your eyes open for the announcements in email. We'll set up most likely a new milestone on the GitHub where we can start tracking some of the work going forward. Great job, everybody. We'll see you in 2 weeks. Bye-bye.
Bye.
Bye.